Welcome to Mysteries of the Universe. I'm your host, Ben Carter, and in today's episode we confront one of the deepest questions ever asked. Why does anything exist at all? Why is there a universe instead of nothing? This mystery has haunted scientists and philosophers alike for centuries, and despite everything we have learned about space and time, the answer remains as elusive as ever. Tonight, we begin that search. For centuries, human beings have stared at the night sky and wondered not only what is out there, but why there is anything at all. Ancient civilizations developed stories to explain creation. In Mesopotamia, the Babylonians described a cosmic struggle between gods whose bodies formed the heavens and the earth. In ancient Egypt, creation myths spoke of a primordial ocean from which the first mound of land emerged, carrying the seeds of life. In ancient India, hymns in the Rig Veda questioned how existence itself could arise from non-existence, suggesting even the gods did not know the answer. These early attempts were not science, but they show that the question of why there is something rather than nothing has been at the heart of human curiosity since the first recorded history. With the rise of modern astronomy, the question took on a new form. In the 17th century, Isaac Newton described a universe governed by physical laws rather than divine intervention. His work implied that the cosmos could be understood through mathematics, but it left open the deeper mystery of why the laws themselves existed. By the early 20th century, Albert Einstein revolutionized our understanding of space and time with his theory of general relativity, revealing a dynamic universe that could expand, contract, and even curve back upon itself. Yet even Einstein could not answer why the universe began at all. In the mid-20th century, discoveries in radio astronomy revealed the faint afterglow of the cosmic microwave background, the radiation left over from the birth of the cosmos. This evidence strongly supported what would become known as the Big Bang model. According to this theory, everything we see today emerged from a state of unimaginable density and heat approximately 13.8 billion years ago. But while the Big Bang describes how the universe evolved from its earliest moments, it does not explain why it came into being in the first place. This question has grown more pressing as physics has uncovered deeper layers of reality. Quantum theory shows that even a vacuum, a seemingly empty space, is not truly empty. It teems with fluctuations, particles appearing and vanishing in a restless sea of potential. If nothingness itself is unstable, could this quantum activity be the origin of everything? Or does it merely push the question back one step, forcing us to ask why the quantum field exists at all? From ancient myths to modern cosmology, the same thread persists. We can describe mechanisms, chart histories, and model physical processes, but the ultimate origin remains shrouded in mystery. This is not simply a question of science. It is a question about existence itself, about the reason anything is here to be studied at all. To approach the mystery of why the universe exists at all, scientists have sought clues in the fabric of reality itself. The earliest light we can observe, the cosmic microwave background, was first detected in the year 1964 by Arno Penzias and Robert Wilson. They were attempting to eliminate a persistent noise in their radio telescope, but instead stumbled upon the oldest signal in the known universe. This faint glow, spread uniformly across the sky, is a remnant of the universe when it was only 380,000 years old. It offers a glimpse into a time before stars, before galaxies, when matter and energy were still forming the structures we now see across the cosmos. From this, astronomers confirmed that the universe is not static, but expanding. The farther we look into space, the further back in time we see. Distant galaxies appear to be moving away from us in all directions. This observation led to the realization that the universe once occupied a much smaller, hotter, and denser state, a singular beginning point. The term Big Bang was first used sarcastically by British physicist Fred Hoyle, who opposed the theory, but it became the accepted description for this origin event. However, this expansion raises unsettling questions. If everything emerged from an initial singularity, what caused that event? What existed before it? And why did it occur at all? Theories abound, but answers remain speculative. According to classical physics, energy cannot be created or destroyed. Yet the universe is filled with energy, locked in stars, swirling in galaxies and pulsing through every particle of matter. So where did it come from? Some physicists point to the strange properties of gravity. Unlike other forces, gravity is negative in energy. It pulls rather than pushes. In a remarkable balancing act, the total energy of the universe may equal zero. Matter provides positive energy, while gravitational attraction provides an equal and opposite negative energy. This leads to the hypothesis that the entire universe could have emerged spontaneously from a state of zero net energy, essentially from nothing, at least in a technical sense. Yet this nothing is not true emptiness. In physics, the vacuum of space is not devoid of activity. Even in the absence of matter, space contains quantum fluctuations, brief appearances of particle pairs that vanish almost as quickly as they arise. These fluctuations have measurable effects, such as the Casimir effect, which demonstrates that so-called empty space exerts forces on objects. In this view, the quantum vacuum is not nothing, but a churning sea of potential. This leads to a provocative idea. Could the universe have emerged from a quantum fluctuation within this vacuum? If such fluctuations occur constantly, perhaps it was only a matter of time before one produced a bubble of space-time large enough to inflate into a full universe. This theory, however, does not eliminate the mystery. It only shifts the question to a deeper level. Why does the quantum vacuum exist? Why do the laws of physics allow for these fluctuations at all? The existence of anything, matter, energy, laws, space or time, demands explanation. Yet no physical theory can yet account for the ultimate origin of being itself. To understand how scientists attempt to answer the question of existence, we must look at the structure of modern physics. At the foundation of reality lie the laws of nature, rules that govern how particles behave, how forces interact, and how the universe evolves. These laws appear to be remarkably consistent. Whether observed in a laboratory on Earth or through a telescope looking deep into space, the same equations seem to apply. This consistency has led some physicists to ask, are the laws of physics inevitable, or could they have been different? One of the most intriguing concepts in cosmology is the idea of a fine-tuned universe. Several constants in physics, such as the strength of gravity, the charge of the electron, or the expansion rate of the cosmos, appear to fall within incredibly narrow ranges that allow matter, stars, and life to exist. If gravity were slightly stronger, stars would burn too quickly. If it were weaker, stars might never ignite. If the strong nuclear force were just a bit different, atoms as we know them could not form. This delicate balance suggests that if the laws of physics were even slightly altered, the universe might be lifeless, or might never have formed at all. This observation raises another layer of mystery. Why are the laws of physics so precisely calibrated? Some argue that this points to a deeper principle, perhaps an undiscovered law that forces such a configuration. Others suggest it could be the result of chance. But chance implies a selection among possibilities, and that leads to one of the most radical ideas in modern science, the multiverse. According to some interpretations of quantum mechanics and string theory, what we perceive as our universe may be only one among countless others. These other universes, if they exist, could each have different physical laws, constants and structures. In this scenario, we find ourselves in a universe that appears fine-tuned simply because only such a universe could give rise to observers like us. This reasoning is known as the anthropic principle. Yet this explanation is far from satisfying to many. For one, the multiverse is, by definition, beyond observation. We cannot see these other universes, test them, or measure them. Their existence remains hypothetical. And even if an infinite number of universes exist, that still does not explain why the multiverse itself exists. Why is there a reality generator at all? Why should there be a realm in which possibilities unfold into actualities? Meanwhile, some cosmologists turn to mathematics itself for answers. They propose that mathematics is not merely a language used to describe the universe, but that it is the fundamental substance of reality. This view, sometimes called the mathematical universe hypothesis, suggests that the universe exists because it is a mathematical structure, and that all mathematically possible structures exist in a timeless realm. Our universe, in this view, is simply one such structure that happens to be experienced as physical by conscious beings within it. This idea stretches the boundaries of science and philosophy, and it forces us to confront the limits of what can be known. Whether the universe is born of quantum fluctuations, spawned from a multiverse, or exists as a timeless mathematical object, the question remains. Why does this structure, this law, this possibility, come into being at all? What gives rise to the very canvas upon which existence is drawn? The dominant scientific explanation for the beginning of the universe is inflationary cosmology, which builds upon the Big Bang model by proposing a period of exponential expansion in the earliest moments of existence. According to this theory, in less than a trillionth of a second after the initial event, the universe expanded faster than the speed of light, smoothing out irregularities and explaining why the cosmos appears so uniform on large scales. The idea of inflation helps solve key problems in cosmology, such as the flatness problem and the horizon problem. But while inflation provides a clearer picture of how the universe evolved from its earliest instant, it does not explain why there was anything to begin with. In an effort to dig deeper, some physicists have proposed that the laws of quantum mechanics allow the universe to emerge from a state of quantum nothing. This nothing is not the absence of everything, but rather the absence of classical space and time. It is a quantum vacuum that contains no particles, no fields, no geometry, but it is still governed by rules. Theoretical physicist Alexander Vilenkin developed a model in which the universe could tunnel into existence from this quantum state. In his view, the total energy of the universe being zero allows for the possibility that the universe did not need an external cause. This concept, though elegant in its mathematical simplicity, raises a difficult philosophical question. If a law allows something to happen, then the law must already exist. But if laws exist, then so does something. What then is the origin of the laws themselves? Who or what writes the rules by which nothing can become something? Science, at least in its current form, has no mechanism for explaining the existence of the laws that underlie the emergence of the universe. This leads many to conclude that we are up against a boundary, not just of physics, but of explanation itself. When cosmologists use equations to describe the origin of the universe, they begin with symbols, structures, and assumptions. But those starting points are already something. Whether one imagines the universe as bubbling out of a quantum vacuum, or as an emergent property of a deeper structure, the notion of true nothingness, a total absence of being, remains elusive. The difficulty in conceiving true nothingness is not just a limitation of science. It is a limitation of the human mind. We are creatures born into a universe of objects, patterns, and continuity. We have no direct experience of absolute non-existence. Even our attempts to imagine nothingness inevitably involve something: emptiness, darkness, silence. But these are still forms, still concepts. Some have proposed that the question itself might be flawed. Perhaps, why does the universe exist is a product of human language and logic, and not a question that corresponds to any real feature of nature. Yet others argue the question is meaningful precisely because it reveals the limits of our understanding. To ask why there is something rather than nothing is to peer into the deepest layer of the unknown, to stand at the edge of all that is and try to see beyond it. The limits of mainstream physics have left a void into which more speculative and unconventional ideas have flowed. While not accepted as established science, these theories attempt to stretch the boundaries of what is considered possible. One such idea proposes that the universe exists because it is a simulation, a deliberate construct within a computational framework far beyond our own. In this scenario, reality as we know it is not fundamental but emerges from encoded rules processed by an advanced intelligence. The question of why the universe exists becomes a question of who or what is running the simulation and for what purpose. This hypothesis gained traction in philosophical circles after the early 2000s, when thinker Nick Bostrom proposed that if any sufficiently advanced civilization could run countless simulations of conscious beings, then it is statistically more likely that we are inside one of those simulations than part of the single original reality. Though untestable with current technology, the simulation idea shifts the question of existence into a framework of intention and design, implying that the universe exists because someone or something chose to simulate it. Other fringe theories look not to intelligent designers, but to consciousness itself. Rather than seeing consciousness as a byproduct of physical processes, some propose the reverse, that consciousness is fundamental and the material universe arises from it. This view echoes ancient philosophical systems such as Advaita Vedanta in India or certain forms of Platonism, which regarded the physical world as a manifestation of a deeper, non-material reality. In modern language, this perspective has been explored through ideas like panpsychism, which holds that consciousness pervades all matter, or idealism, which asserts that mind is the ground of all being. These theories, while outside the scope of testable science, raise a compelling point. If our current models cannot account for the origin of the universe because they begin with physical assumptions, perhaps the origin lies beyond the physical altogether. In this case, the laws of physics, the structure of space and time, and even the notion of causality might be emergent properties rather than fundamental realities. This would mean that the very tools used by science to explain existence are themselves part of what needs to be explained. Another radical idea proposes that the universe is self-creating. In this view, the past and future are linked in such a way that the universe brings itself into existence through a closed loop of causality. This resembles concepts in time loop theory or retrocausality, where effects can influence causes. Though deeply counterintuitive, such ideas are not ruled out by all interpretations of quantum mechanics. In the absence of definitive answers, these speculative frameworks serve a valuable role. They push the boundaries of thought and keep the mystery alive. They remind us that just because something cannot yet be proven does not mean it is not worthy of consideration. If anything, the diversity of ideas, simulation, mind-first realities, self-creating loops, reveals how unprepared we are to confront the absolute origin of all things. And yet it also shows how deeply human beings are compelled to ask the question, to wonder, to imagine, to refuse to accept that the universe simply is, without reason. Beneath the scientific models and speculative theories lies an even older approach to the mystery of existence, one rooted not in equations, but in philosophy. For thousands of years, thinkers have grappled with the question of why anything exists at all. The ancient Greek philosopher Parmenides argued that nothing cannot exist, because to even speak of it gives it a kind of being. In contrast, his successor Democritus imagined a void in which indivisible atoms moved, an early attempt to reconcile being with nothingness. Centuries later, the German philosopher Gottfried Wilhelm Leibniz asked the same haunting question: why is there something rather than nothing? He proposed that the answer must lie outside the physical world, in a necessary being, something that must exist and contains the reason for its own existence. For Leibniz, this necessary being was God, but his logic has remained influential even among those who do not embrace a religious framework. The concept of a necessary being challenges the idea that the universe is an accident. If something exists necessarily, it cannot not exist. It exists by its very nature. The laws of logic and mathematics are often cited as candidates for this kind of necessity. They are not physical objects, yet they appear timeless and unchanging. No matter when or where, 2 + 2 = 4. Some philosophers argue that existence itself, or the possibility of existence, might be a necessary truth. If that is so, then something must exist in some form. Others challenge this reasoning. They point out that necessity may be a property of language, not of reality. Just because we cannot conceive of a world without logic or mathematics does not mean that such a world is impossible. Moreover, defining existence as necessary does not explain the specific features of our universe, its galaxies, stars, laws, and life. Why does this reality exist, with its particular structures, rather than some other? Some traditions approach the question from a spiritual or mystical direction. In Buddhist philosophy, the concept of emptiness does not mean nothingness, but rather the absence of inherent, independent existence. Everything is seen as interdependent, arising through causes and conditions. In this view, existence is not a static thing, but a process, dynamic, contingent, and ultimately beyond fixed description. In other spiritual systems, such as Kabbalah or certain strands of Gnosticism, the material universe is seen as a reflection, or even a shadow, of a more profound spiritual reality. The world exists not as a final destination, but as a stage in the unfolding of consciousness, a journey of return to a source beyond form and thought. In both philosophical and spiritual perspectives, the mystery of existence is not something to be solved, but something to be lived with, contemplated, honored, and perhaps never fully grasped. These traditions suggest that the question itself may be part of the answer, that the human capacity to ask why the universe exists is a reflection of something profound within us, a mirror of the mystery we are trying to understand. As we move through the many layers of this question, patterns begin to emerge, not in the form of answers, but in the shape of the mystery itself. Science offers models, philosophy offers frameworks, spiritual traditions offer metaphors, but none can fully dissolve the strangeness of the fact that existence, in any form, is real, that there is not absolute nothing but a vast unfolding something. Galaxies swirl, particles collide, conscious minds wander, and every attempt to trace it all back leads to another layer of questions. The observable universe contains hundreds of billions of galaxies, each with hundreds of billions of stars. It operates according to laws of immense complexity and precision. Yet no equation, however elegant, has yet revealed why the canvas exists at all. Why is there any space in which laws can operate? Why do those laws hold? And what determines their character? We often speak of the universe as a physical system, but beneath that system lies an assumption so easily overlooked, that the universe is here to be studied in the first place. Attempts to bypass this problem by appealing to inevitability fall short. If one says the universe had to exist because it was possible, that merely shifts the mystery to the nature of possibility. If one says that existence is better than non-existence, one must explain what standard of value applies before anything exists. If one says the universe is self-creating, then selfhood, process, and causality must be accounted for in the absence of all structure. Each answer opens a deeper question, and yet, in this recursive spiral of uncertainty, there is something deeply human. The impulse to explain the universe is itself part of the universe. Our minds, shaped by evolution, are capable of constructing particle accelerators and poetry. We map the cosmic background, decode subatomic patterns, and ponder the purpose of it all. This capacity for abstract thought appears to be a unique feature of the universe, one that raises the possibility that meaning and mystery are not merely byproducts of consciousness, but part of what the universe expresses through it. Some have argued that the question, why does the universe exist, may be unanswerable in principle. That it is, in essence, a boundary condition of thought itself. Just as we cannot see beyond the edge of the observable cosmos, we may not be able to think beyond the frame of existence. All our concepts, time, space, cause, identity, presume that something already is. We have no language, no symbols, for the complete absence of all that. But perhaps the goal is not to explain the mystery away, but to learn to live within it. To see that the question has value not just for the answer it might yield, but for how it changes our relationship to reality. The awareness that existence could be otherwise, or might not be at all, infuses each moment with depth. It makes the universe not only a place, but a question. Not only a system, but a riddle. A riddle whose presence is undeniable, even if its meaning remains just out of reach. From the smallest particles to the largest galactic structures, the universe follows patterns. It evolves through cycles of formation and destruction, from the birth of stars to the collapse of black holes. In every corner of the cosmos, we find structure and process, energy and change. Yet all of this, all the complexity and beauty, floats atop a single persistent enigma, the bare fact that anything exists to begin with. Every scientific model, every philosophical theory begins only once existence is already granted. No method, however refined, has yet explained why there is a stage at all on which the universe can play out its drama. Many thinkers have tried to summarize the mystery using the language of paradox. If nothing is the default, then something must be explained. But if something is the default, then nothingness must be impossible. Either way, we are forced to question assumptions that have shaped all human reasoning. Is non-existence really more natural than existence, or is being itself the only thing that could ever be? This dilemma has haunted some of the most brilliant minds in history. Physicist Steven Weinberg once wrote that the more the universe seems comprehensible, the more it also seems pointless. And yet, the search for meaning persists. Nobel laureate Roger Penrose has suggested that mathematics, consciousness, and the physical world are three aspects of the same mystery, deeply entangled in a way we do not yet understand. Others have speculated that our universe is not a final reality, but a shadow of a deeper, unknown order. Throughout history, many cultures have expressed this same feeling through myth. The Norse spoke of a yawning void called Ginnungagap, out of which all things emerged. In ancient Chinese cosmology, Tao is the underlying force that gives rise to being from non-being. In Jewish mysticism, creation begins with a withdrawal, an intentional contraction of the infinite to make space for the finite. These myths, though not science, echo a truth science cannot dismiss, that the question of existence may not yield to explanation, but may instead point to something beyond explanation itself. Perhaps the most haunting aspect of the question is that it cannot be escaped. We are within the universe. We are made of it. Our bodies, our thoughts, even our questions arise from the same fabric we are trying to understand. This makes the question of existence not just a scientific or philosophical issue, but a deeply personal one. To ask why the universe exists is also to ask why we are here, why this moment exists, why there is awareness. In this way, the mystery turns inward. The cosmos, vast and cold, becomes a mirror, and in its reflection we find not answers, but the shape of the question written in stars, in atoms, in ourselves. So we arrive at the end of our search, though not at an answer. The question remains, unmoved, unsolved. Why is there something rather than nothing? It has withstood every telescope pointed at the stars, every particle smashed into its components, every line of code run through a simulation. Theories have risen and fallen, from ancient myths to quantum vacuums, from divine necessity to spontaneous emergence. Each seeks to pull back the veil, to find the first cause, the uncaused cause, the explanation behind existence itself. But each, in the end, must begin with something. A principle, a field, a spark. That spark may never be found. Or perhaps it cannot be found because we are made of it. Perhaps the origin of existence is not a point in time, but a feature of being itself, something woven into the very possibility of consciousness and thought. It may be that reality is self-justifying in a way we do not yet understand. Or that the question is its own kind of answer, that by asking it we reveal the depth of the mystery in which we are all suspended. From distant galaxies to subatomic particles, from time's arrow to the laws that bind it, all of it is perched on a single incomprehensible fact, that something is. That space stretches in all directions, that matter moves, that minds reflect. This existence, so often taken for granted, is in truth the greatest marvel. A universe not only capable of supporting life, but of asking its own origin. Perhaps, then, mystery is not a failure of knowledge, but the natural state of things. A reminder that even the most precise instruments and equations cannot measure the whole of being. There will always be a remainder, a question that sits just outside the reach of logic. A silence beneath the music, a presence behind the form. In this silence, many have found awe, others have found faith. Some find only questions and are content with that. But all who gaze into the cosmos must, at some point, feel the weight of that ancient question pressing inward. It is a question older than stars, deeper than time. Why is there something anything rather than nothing at all? Thanks for listening. This has been Mysteries of the Universe. If you enjoyed today's episode, be sure to follow us wherever you get your podcasts. And if you'd like to support the show and unlock bonus content, subscribe to the Forbidden Knowledge Network on Patreon. Subscribe now.